Hello everyone, welcome back to my channel NISHNATH-all. Today let us learn quantum numbers from atomic structure, chemistry. Quantum numbers, they are actually divided into four parts. They are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. There are four types of quantum numbers. Quantum numbers. What is the definition of the quantum numbers? It specifies the location and energy of an electron in an atom and is a measure of the effective volume of the electron cloud. Quantum numbers are proposed in order to know the complete information regarding the position of electron in an atom. There are four types of quantum numbers. They are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Principal quantum number. This is our type 1 quantum number. This quantum number was introduced by Niels Bohr. It explains about the origin of lines in the spectrum of hydrogen, number of the orbit, size of the orbit, energy of the orbit. The value of n are taken as 1 to 3 and represented as KLMN. The radius of the nth orbit formula is 0.53 into n square by z angstroms. Energy of the electron formula is minus 13.6 by n square into z square eV by atom. For example, the number of electrons in any orbit is given by the formula 2n square. And this is the table of orbit number and name of the orbit and number of electrons. Let's go to the second type of quantum number, that is azimuthal quantum number. Azimuthal quantum number. Before learning that, let's learn what is the meaning of orbital. The three-dimensional space around the nucleus in an atom where probability of finding an electron is maximum is called orbital. For an atomic orbital, the electron has fixed energy and its angular momentum is fixed. The angular momentum of orbitals are quantized like the energies, that is, they can have specified values. As principal quantum number is used to specify energies of the electron in various states, the orbital angular momentum quantum number is used to specify the orbital angular momentum. This quantum number was introduced by Sommerfeld. Orbital angular momentum formula is equals to square root of L plus 1 into h by 2 pi. Example, when L is equals to 0 is no nodal plane in the wave function and the orbital is spherically symmetric about the nucleus. Since the total number of nodes is equal to NL, can have positive integral values from 0 to n minus 1. Let's take one more example. If n equals to 5, L can be 0, 1, 2, 3, 4. The azimuthal quantum number tells us about the shape of the electron cloud. The greater the value of L, the more diffused is the electron cloud. It gives the information about the subshells and the shapes of the orbitals. It tells about the subenergy levels, subshells. Azimuthal quantum number explains about the subshells. The value of L depend on the values of n, and L takes the value from 0 to n minus 1. Let's take one more example. If n equals to 1, it is known as K shell. Then L equals to 0 is known as S subshell. When n equals to 2, it is L shell. L equals to 0, 1 are called S and P subshells respectively. When n equals to 3, M shell, L equals to 0, 1 and 2 are called SPD subshells respectively. The number of subshells on any given shell in any given shell is given by the formula n square. Let's take one more example. The first shell contains only one subshell. The second shell contains two subshells. The number of electrons in any given subshell is equals to 2 of 12 plus 1. Number of shells and subshells table. In this table we can learn shell name, shell number, subshells, and what is the value of L, number of electrons in filled shell, number of electrons in filled subshell, and magnetic quantum number. It was introduced by Landé. It indicates spatial orientation of the orbital or presence of orbital in a subshell. Its value depends on the value of L, and it can take only integral values ranging from minus L to plus L. The total number of values of M indicates the number of spatial orientations of the orbital, that is 12 plus 1. The number of orbitals in any given orbit is equals to n square. Magnetic quantum number is denoted by m, small m. You can see the blue color table down of the text which I written. Okay, let's see the table. Name of the subshell, we can learn name of the subshell and L values, M values, number of orbitals, and name of the orbitals by this table. Let's go to next one. Spin quantum number. This is our last fourth type of quantum number. Spin quantum number. 3 quantum numbers are necessary to describe the spatial distribution of electrons in atoms. To describe an electron in an atom completely, a fourth quantum number S is called spin quantum number must be specified. This is because every electron is associated with a magnetic moment which is quantized in one of the two possible orientations, either parallel or opposite to an applied magnetic field. Spin quantum number is denoted by small s. When spectral lines of H, hydrogen, Li, lithium, Na, sodium, and K, potassium, etc. were observed by means of an instrument with high resolving power, each line of the spectral series was found to consist of pair of lines known as doublets or double line structure. Here it should be understood clearly that this doublet is different from spine structure which consists of closely spaced fine lines, not widely separated ones. To account for these doublets, Unhenbeck and Goudsmit suggested that the electron, while moving around the nucleus in an orbit, also rotates or spins and its own axis either in clockwise direction or anti-clockwise direction. S can have two values plus half corresponding to the spin of the electron in clockwise direction or minus half corresponding to the spin of the electron in the anti-clockwise direction. Clockwise and anti-clockwise spins are represented as upwards arrow mark and downwards arrow mark. Two electrons with the same size of spin quantum numbers are said to be parallel spins, shown as upside arrow mark and upside arrow mark, while those opposite signs of spin quantum numbers are said to have opposite spins or anti-parallel spins, upwards arrow mark and downwards arrow mark. The electrons having opposite signs are called paired up electrons. Thank you for watching, and if you like this video, please like the video and share the video, and please subscribe to NISHNATH-all for more videos. Bye.